So what if the college degree you are, applying for right now is basically destined to become obsolete before you even walk across the graduation stage?
I mean, it is a really jarring thought, especially when you think about how much pressure is on high school seniors right now.
Oh, yeah.
And people advising them, too,
Yeah.
they have to make this perfect choice about their future, and the landscape is shifting so
Right,
fast.
exactly. And if you're listening to this deep dive, you are probably standing at this very specific high-stakes intersection. You're looking down one road and it says business.
Yeah,
And you imagine, like, the boardroom, the strategy sessions, learning how to manage teams and market some massive global product.
sure.
But then you look down the other road and it says computer science.
hmm
And that is the road of code, algorithms, artificial intelligence, and building the actual digital infrastructure of the world.
And historically, society has treated those as two completely, entirely separate species.
Well,
You have the person who writes the software, and you have the person who sells the software, and they usually do not speak each other's language.
at all, which leaves you in a bind. You want the strategic leadership of a CEO, but you look around and see that the entire future runs on code.
Right.
You don't want to be left behind by the tech wave, but you also probably don't want to spend your life locked in a back room just staring at a compiler.
No one does.
Right. So today, our mission for this deep dive is going through a stack of materials from UK Petra's International Business Engineering Program, or IBE. We're going to explore how this specific program is attempting to basically completely dismantle that dilemma.
And they approach this dilemma by making a pretty aggressive argument right out of the gate. The sources we're looking at suggest that single-track degrees, meaning, you only study business or you only study tech, are just increasingly dangerous in the current market.
Dangerous because of AI, right?
Yeah.
I mean, I was reading their premise, and it essentially says if your only skill is writing standard code, an AI can do that,
Huh?
and it can do it for cheaper.
Exactly. But then on the flip side, if your only skill is abstract business management and you don't actually understand how the underlying data systems work,
Your decision-making is going to be painfully slow.
precisely, you just end up being outpaced by competitors who actually use automation to their advantage. So to solve this, the IBE program proposes a totally different educational model.
Okay.
They want to create what they call the integrated leader.
I like that term.
Yeah, it's someone who blends coding logic, deep data analytics, and business intuition so they can actually command AI and lead complex technical teams.
And they summarize it with this motto, which I love. It says, think like an engineer, lead like a CEO.
It's a great hook.
It is. But I mean, anyone can write a catchy slogan on a brochure. I want to know how you actually build a curriculum that turns an 18-year-old into someone who can do both of those things without just, watering down both subjects.
Well, that is the critical test of any hybrid program, because if you just staple a few coding classes onto a marketing degree, you haven't created an integrated leader.
No, you've just created a distracted business student.
Exactly. So we have to look under the hood at the structural architecture of their curriculum to see if the math actually adds up.
Okay, let's unpack their curriculum breakdown because the percentages they use are really counterintuitive. Like if someone told me they were creating a hybrid business engineering degree, I would assume it's a 50-50 split.
Right, that would make sense.
But IBE does a 40-30, 15-15 split. The largest chunk, by far 40%, is dedicated to systems and operations.
And that 40% is really the key to understanding the entire philosophy of the program, because a system, in this context, isn't just a computer network.
Okay, what is it then?
A system is how a business actually breathes and moves. It's the global supply chain, it's the manufacturing floor, it's the logistics of getting a product from a warehouse in Jakarta to a doorstep in Berlin.
Right. And then the rest of the pie chart is 30% basic science and liberal arts, 15% tech and coding, which covers AI integration and databases, and then only 15% dedicated to traditional business strategy.
Yep.
Which honestly made me pause. I mean, how do you learn to lead like a CEO if only 15% of your time is spent on business strategy?
Well, because modern business strategy is no longer just about reading management case studies from the 80s. It is about optimizing those massive systems.
Ah, I see.
Yeah, by weighting systems and operations so heavily, they're teaching students to look at a multinational corporation as one giant interconnected machine. The 15% business strategy teaches you where the machine needs to go.
And the 15% tech gives you the data to steer it.
Exactly. But that massive 40% in systems, That teaches you how the machine actually works.
Okay, let me try out an analogy here to see if I'm grasping the mechanism correctly.
Go for it.
Getting a pure business degree is like learning the real estate market. You know how to value a house and sell it to a buyer.
Okay.
And getting a pure computer science degree is like learning to lay bricks, pour concrete, and, run electrical wiring. The raw materials.
That's a fair comparison. So where does IBE fit in?
IBE is teaching you to be the city planner who designs a smart city. You don't need to lay every single brick yourself, but you have to understand the tensile strength of the concrete while simultaneously understanding how the traffic flows will impact the local economy.
Yes.
And how to zone the commercial districts to maximize revenue. You're optimizing the entire ecosystem.
That is spot on. But designing a smart city requires incredibly sophisticated tools. You aren't doing that with a pencil and paper.
Definitely not.
And this is where the materials really caught my attention. The sources detailed this enterprise infrastructure. Students aren't just using watered-down academic versions of software to run little simulations.
Oh, right, I read this part. They are working inside live cloud computing environments.
Yeah, and they're handed full access licenses to enterprise business intelligence software. Specifically, the materials highlight platforms like MicroStrategy and Guandata.
So I need to pause here and ask for some clarification, because a lot of listeners might hear business intelligence software and just picture a really fancy, colorful Excel spreadsheet.
Oh, it is a massive leap from a spreadsheet.
Okay, what exactly are MicroStrategy and Guandata, and why is it such a big deal that college students are using them?
Imagine a global retailer like Amazon. They have millions of data points generating every single second. Inventory levels in 1,000 warehouses, weather patterns affecting shipping routes, real-time shifts in consumer search habits.
The regular spreadsheet would just crash instantly trying to process that.
Instantly. So business intelligence software is what handles that kind of scale. Software like MicroStrategy ingests all that chaotic, massive data and synthesizes it into live, interactive dashboards. It allows an executive to look at a screen, notice that shipping delays in the Pacific are causing inventory shortages in Europe, and instantly model how much it would cost to reroute the supply chain through the air instead.
And usually, a university grad enters the corporate workforce having literally never touched that software.
Never.
They spend their first 6 to 12 months on the job just taking internal training courses, trying to figure out how to pull a basic report without breaking the whole system.
Which is a tremendous drain on a company's resources. So by embedding this enterprise-grade infrastructure directly into the coursework, IBE guarantees their students are operating at a mid-level professional capacity before they even finish their degree.
That's a huge head start.
It is. They already know how to architect the data and interpret the dashboard. The program calls this making their students future-proof.
Right, because even if a specific software interface changes in 5 years, the student already understands the underlying logic of enterprise data architecture. But, knowing the software in a classroom is one thing. Doing a simulation where the data is clean and your professor gives you the parameters is safe.
Very safe.
There's a massive difference between that and sitting in a boardroom where millions of dollars are on the line, the data is messy, and executives are yelling at each other.
Yeah.
How do they actually simulate that kind of pressure?
Well, they don't simulate it. They mandate that the students experience it for real.
Wait, what do you mean?
The curriculum structure requires a practicum in semester 7, where the student steps completely out of the academic bubble.
Oh, right, the 3 paths.
Yeah.
The sources outline this.
Yeah.
So for this practicum, you can launch an independent digital venture in the entrepreneurship path.
Yep.
You can do international study in the global immersion path, or you can take the corporate internship path, which literally expects students to deliver actionable value inside multinational corporations.
And the roster of corporate partners they've built for these internships is quite revealing. We are talking about UBS in global finance,
Okay, that's huge.
Toyota in advanced manufacturing, Schneider Electric for global energy management, plus major e-commerce players like Blibli and massive regional conglomerates like HM Sampoerna.
Okay, wait, hold on. I have to challenge this premise for a second. You're telling me a 21-year-old college junior is being dropped into Toyota's advanced manufacturing supply chain,
Yes.
or UBS's financial data systems. That sounds like a recipe for a complete disaster. How are they not just fetching coffee or doing basic data entry?
It is a natural skepticism, right? Because in a traditional educational model, dropping a junior into Toyota would be a disaster. They would only know abstract theories from a textbook. But remember the infrastructure we just discussed.
The 40% focus on systems and the MicroStrategy experience.
Correct. This is the cornerstone of their real-world first pillar.
Yeah.
These students aren't showing up to their internship asking how a supply chain works. They're showing up knowing how to build a predictive data model to optimize that supply chain.
Oh,
Yeah, the goal of Semester 7 isn't to just shadow an employee. It's to build a portfolio of actual implemented solutions.
portfolios over papers. I love
Yeah.
that because the market doesn't care if you wrote a great essay on logistics, right? It cares if you can point to a time you actually optimized a logistics network and saved a company real money.
Exactly. And this requires a very specific type of guidance. If you are going to operate at the level of UBS or Schneider Electric, a standard academic professor who hasn't worked in the industry for 20 years might really struggle to give you relevant advice.
Which naturally leads us to the people actually teaching and guiding this program. Because to survive at that level, you need mentors who have already conquered the modern global market.
You do.
The IBE program heavily promotes its Global Ready pillar, which mandates 100% English fluency. But the actual faculty list is what really stands out to me.
It's a roster deliberately designed to provide multiple high-level perspectives from the epicenters of the tech industry.
I had to read this source twice to make sure I was getting it right.
It's pretty impressive.
The mentors include a senior product designer at Apple, based in Cupertino, California.
Yeah.
There's an ex-vice president and principal architect at MicroStrategy, who is now working as a Gen AI engineer in Maryland. They have a resident solution engineer with Databricks, located in New York, plus international professors from Taiwan and Korea.
Let's consider the mechanism of why that actually matters. Take the mentor from Databricks in New York.
Okay.
Databricks is a massive, unified analytics platform handling colossal amounts of big data for enterprises. A resident solution engineer there spends every single day looking at how the world's biggest companies structure their messy, chaotic data.
So when an IBE student in Indonesia is trying to figure out how to structure a database for their Semester 7 internship project, they aren't just getting theoretical advice.
No.
They're getting feedback from someone who designs data structures in New York for a letting.
Exactly. It fundamentally shifts the student's perspective. By learning directly from people building the tech infrastructure in Silicon Valley or New York, the students learn global tech strategies, not just regional business tactics.
And they expand that footprint through their academic partners, too. Like, there's a dual degree program with NUAA, the Nanjing University of Aeronautics and Astronautics, where you can split your 4 years between the two campuses.
Yes.
They're also building a +1 program with the University of Maryland's Robert H. Smith School of Business.
It totally prevents insular thinking. Because if you want to understand how a global supply chain works, you need to understand how business operates across different cultures, different regulatory environments, and different technological standards.
So we've established a pretty intense profile here. You have a student who understands heavy enterprise software, who thinks in terms of complex systems, who is building a portfolio at multinational companies, and who is being mentored by engineers at Apple and Databricks.
It is a lot of firepower.
It is, but it begs the question, to what end?
And that is always the danger with pure data science or pure engineering. You can become so obsessed with optimizing the numbers that you completely forget why you were doing it in the first place.
Right, but the IBE materials are very explicit about their philosophical core. They summarize it as heart, mind, and touch.
A great philosophy.
The program actually states that they don't just teach you how to analyze data, they teach you how to use technology to make a meaningful human impact.
Which is vital, because tech without a human application is really just cold numbers rendering on a screen. A truly integrated leader understands that data is a tool to solve human problems, not just an end in itself.
Sure, but anyone can claim they care about human impact, right?
True.
But the sources provide a really compelling proof of concept here. In 2021, 3 IBE students, Gloria, Lavinia, and Panka, entered the USCL Lab competition.
Yes, the undergraduate statistics class project competition.
Right, and they took first place.
And who did they beat to secure that first place finish?
Teams from Duke University and the University of Notre Dame, which is an incredible David and Goliath story on its own.
It really is.
But the fascinating part is how they won and what they actually chose to study. Their winning project was an analysis of the impact of education, population, and unemployment towards poverty rate worldwide.
that perfectly isolates the meaningful human impact they're striving for.
Yeah, let's look at the mechanics of that victory, because it perfectly illustrates this business-tech hybrid we've been talking about. A traditional business student might look at global poverty and try to write a policy paper on microloans, but they wouldn't know how to statistically model the data.
Exactly.
A traditional computer science student could write a brilliant machine learning algorithm to sort the unemployment data, but they might not understand the macroeconomic context to draw a meaningful conclusion from it.
But these IBE students approached it as an integrated system. They used the technical rigor of an engineer, the heavy statistics and data mining, to process massive data sets regarding education and population. Then they applied the systemic vision of a CEO to translate those raw numbers into a coherent narrative about the actual drivers of global poverty.
They weren't just using advanced statistics to figure out how to get teenagers to click on more digital ads.
No.
They were leveraging their tech skills to analyze massive socioeconomic disparities.
And that standard of excellence, it translates when the students participate in the global immersion paths as well.
Right. The sources highlight a couple of striking examples of students studying abroad. There's Tamara Regina Dharmawan, who secured the first place Women in Technology Award while on exchange at the University of New South Wales in Australia.
That's fantastic.
And Felicia Jansen-Widio, who went on exchange to the University of Otago in New Zealand, was named top of class and subsequently secured a full scholarship from the Chinese government to pursue her master's at Tsinghua University.
These outcomes really validate the architecture of the program. It isn't just effective in a local context.
Definitely not.
The hybrid curriculum produces students who can compete and lead on a global stage against peers in Australia, New Zealand, the US, and China.
Now, making a positive impact on global poverty is noble, and winning global competitions is a great resume booster. But let's ground this in practical reality for a second.
Let's do it.
The listener tuning into this deep dive, the high school senior agonizing over their college applications, they need to know how this translates to an actual sustainable career.
Well, it is the ultimate question of return on investment, isn't it?
Exactly. And beyond the career prospects, there's the immediate reality of how a student might actually fund this kind of specialized education.
Fair point.
Let's tackle the careers first. The materials outline several very specific, highly lucrative career paths for graduates.
Because they aren't graduating with a generic management degree, they completely bypass those entry-level generalist roles.
Right. The sources list target careers like data scientist, analytics manager, business intelligence engineer, and business analytics specialist.
Let's examine why those specific roles command such high salaries in the current market. As we discussed earlier, most companies have a massive translation problem.
What do you mean?
The executives in the boardroom speak strategy and revenue. The engineers in the server room speak Python and SQL.
And they constantly frustrate each other.
Always.
The executives want answers yesterday, and the engineers are frustrated because the executives just don't understand the technical constraints of the data.
Exactly. An analytics manager or a business intelligence engineer is the translator. They can sit in the boardroom, understand the strategic goal, say, reducing customer churn by 5%, and then walk right down to the engineering floor and architect the specific data queries needed to find the answer.
Wow, yeah.
Companies will pay a massive premium for someone who eliminates that friction and speeds up decision-making.
Which brings us to the financial side of acquiring these skills. The sources detail something called the Guandata Scholarship, and it looks like a major catalyst for students entering this program.
It is framed not just as financial aid, but basically as a career launch pad.
Yeah, it offers 100% course fee support for up to 1 to 2 years, which immediately removes a massive barrier. But the structure of the scholarship is what really caught my eye. It's heavily tied to that real-world first mentality.
How so? What are the specific requirements tied to the funding?
The scholarship includes a paid global internship where the student works directly on real-world enterprise data analytics projects.
Oh, wow.
Right. And by the end of it, they walk away with a global AI and BI certification. So they aren't just getting their tuition paid, they're being handed the exact enterprise experience and industry certifications that justify those high-paying analytics manager roles we just talked about.
It creates this sort of compound interest effect on their career. They graduate without the burden of those specific tuition fees. They're armed with a portfolio of global enterprise projects, possessing a recognized certification in artificial intelligence and business intelligence.
And holding a degree that proves they can synthesize engineering and management. So let's bring all of this together. If you are that high school senior or the advisor trying to help them navigate this incredibly stressful fork in the road, what is the ultimate takeaway here?
The takeaway is that the market has fundamentally shifted. The old categories are dissolving. The modern global economy just doesn't want isolated coders, and it certainly doesn't want managers who are intimidated by a data dashboard.
The companies shaping the future are actively hunting for data-driven business leaders.
And that means you don't actually have to choose between your interest in business and your fascination with technology.
Right.
Programs like IBE are serving as the bridge. They offer a framework where you can learn the deep systems thinking required to manipulate enterprise software while developing the strategic vision to apply that tech to global markets.
Little fluency.
Yeah.
You can be the person who speaks both the language of the machine and the language of the market. And according to the IBE philosophy, that dual fluency is your greatest defense against becoming obsolete in an automated world.
The materials pose a stark, almost confrontational question that I think perfectly distills the stakes of this deep dive. They ask, the AI era is here. Will you be replaced by AI, or will you architect it?
That really is the bottom line.
Yeah.
If you only know how to perform a routine task, whether that's writing basic code or filling out a basic ledger, an AI is eventually going to do it faster.
Without a doubt.
But if you understand the systems, if you know how to wield the enterprise tools and direct the technology toward a strategic goal, you become the architect. You become indispensable.
Well said.
So here is a final thought to leave you with today, building on everything we've covered. Imagine you have gone through this crucible. You have the advanced data mining skills of a top-tier engineer, the global perspective of a mentor from Apple or Databricks, and the strategic vision of a CEO.
It's a powerful combination.
With all of those tools sitting right there in your hands, ready to be deployed, what massive, real-world human problem would you choose to solve first?